Hey guys, welcome back to AlgoYogi, and we are doing the tree series right now. We're done solving all the easy questions. Let's move on to little tricky questions, medium level LeetCode trees problem. So let's go to LeetCode, and today's problem is construct string from binary tree. So I hope you guys have already been through this whole description. Entire description here is asking us to basically return the pre-ordered string representation of a binary tree, but then there are some rules. We'll go over them. So I have gone through it, and let me summarize it for you guys. So let me change the view, and let's go over the summary of the problem description. Now it says we have to construct a string of a binary tree, and since different binary trees should have a different unique string representation, that's why there are certain rules, right? And the rules are, first is basically following the pre-order traversal. That's first thing we have to do. Second rule is the order should be the root value first, and then whatever left subtree is going to return us the values, that would be in parenthesis here. That will be in parenthesis right next to our root value. And right after that, we will have the right subtree values. Okay, the right subtree values right here, and that will also be in parenthesis. So this is it. So we're going to have root value, and then we're going to have left subtree values. And see, like, this is a recursive structure, so this might contain more values. That's what we have to understand. Then, but it's just we're imagining that we're going to have root value. If it is a simple tree, then parenthesis left subtree value, parenthesis right subtree value. Now there is a little trick here. Like, these are like edge cases. They have given some edge cases conditions as well. So now let's go over those. So it says omit all empty parentheses except when right child is there, right child is present, but left child is not present. But left child is not present. So this is one condition where if we find empty parentheses, then we have to remove it. So in the condition, in the summary, it said we have to remove all the empty parentheses except one condition, and that would be when we do not have a left child but have a right child. If we have a left child, we do not have a right child, omit it, just remove it. So now let's see some examples here. So if we have just root here, then it's going to return the root value. Okay, it left and right, they're basically none. So it's going to have, initially when we're constructing this string, it should look like this. However, we have a condition, we're going to omit everything here, these empty parentheses. Okay, so now let's see this second example. Here it will be the root value, left subtree and right subtree. This is it. Now this is the condition where we gonna apply this third rule, and that would be if we do not have a left child, of course we're gonna have the left the root value, and then we do not have a left subtree, so, or left child, then we're going to have an empty parenthesis, and then the right value in the parenthesis. So this would be our string for this particular binary tree. And now let's go over the examples. Here they have given, these two trees are kind of similar, but just one exception, one change, and that is this particular node. And this node is basically changed from left to right, and this is what is going to tell us what we are actually, uh, what difference we are making when the left child is not present and right child is present, but or right child is not present but the left child is present. So this is what we're going to, this is where we're going to see the difference, and that would be here our representation is going to come like root value, and then we're going to process the left subtree. That would be again when we're processing this left subtree, that would be the value of root, and then now we're going to process in the parenthesis its left subtree, that would be 4. Now this doesn't have a right subtree, so we're gonna have this, but we're gonna omit this because for right child, if it is not present, we're gonna omit it. That's what we learned in the conditions. And then we're gonna close our left subtree, which is, we are done processing our left subtree here, and then we are going to process the right subtree, which is this, which will also be in our condition here. Okay, in parentheses, not the condition. I mean, this is the right, this is left, this is right, and this was root. So that should be our answer for our first example. Now the second example, this is the second example. Here just one twist, and that twist is root value. Let's process the left subtree, that would be left subtree root, and then processing its left, which is not present, but its right is present. Then we're gonna have for left we're gonna have empty string, empty parenthesis, and then we're going to have the right subtree, and finally we're going to close this, and then we're going to have the right subtree right here, this one, that would be 3. So here it's just this extra parenthesis you are seeing. If you try to compare the answers for first example and the second example, so this is the only difference. Okay, so let's implement it. It's really simple. When we're implementing it in the solution, it's really simple, but I think by now, like, you're clear how we are building this string from these examples, when the right child is present and left is not, and if left is present and right is not. So just okay, so let's implement the solution. Now I'll create a simple helper function with the name post order, and the reason I'm calling it post order is because we are implementing the post order traversal. Now it's just what we are returning will be a little different. If I don't know why I'm typing return empty. If root is none, then we return empty string. Okay, then we return empty string. Otherwise we're going to have, let's call it root value, that would be root.val. okay, and we're going to process the left subtree, that would be, so this is how we process left and right subtrees, guys. Okay, in post order we process left first root, and then left, and then we process the right. So let's process the right. Okay, so we have certain conditions that we already went over. The conditions are, if we have left and right both child of a node, then we simply return, let's make it string, because it will be easy for us to return it by concatenating with the parentheses. So it's going to be our root value plus and then here we're gonna have left, and then we're gonna close it. So I'm gonna have this, and then the same way, because both children are present, then we're gonna process right side. Cool. And what if not, if elif left, or maybe that's just not elif. I mean, it's not the elif condition, it's just if condition, because if this happens, oh no, sorry, I think it is elif, because we don't want to process left, will be there if left and right is processed. So if only left, then we want to return, we will omit the right side. Okay, we don't need this because this will return us empty, so we don't want this side at all. Okay, however in a case where I think we'll need another condition, which is right. If only right, that means left wasn't present, but at left we have to send the empty value, so which would be just this, but at place of left we're sending nothing but an empty parenthesis. Okay, and in the end, if let's say none of these conditions match and only the root value, then we just return root val. Okay, finally we just return the root val. Okay, now let's call this function, which is our post root, and we can just simply return it. Cool. I think this is simple. We have done what we talked about, which is if root is none, just return the empty string, then process left and right, and first process the root and root value, and when you're returning based on if left and right child, like if based on if they're none or not, we are returning them as if right is present and left is not, then in place of left you just return this empty string if only right is present, and if only left is present, then just omit the entire right side. Okay, so that's cool. Let's try to run it. Okay, and let's see if this is accepted. Okay, pretty cool, accepted. Now let's write down its time complexity. Time complexity would be big of n, because we're visiting, and n is the number of nodes, right? N is the number of nodes. That many times we are visiting all the nodes. Space complexity here would be what it would be, big of h, or we can even say, since so it will be big of h, and h could be equal to n, as we have always talked about, so you can mention it either h or n, given how many at a given point maximum nodes we have on the stack, implicit space complexity. Okay, so this is done, and let's go back to our AlgoYogi and mark this problem, first medium problem from trees section, solved, and see you in the next problem. Okay, bye bye.